Hello everyone, I hope you're doing well. Welcome back to another video in our Introduction to Calculus playlist. So in the previous video, we were continuing with solving special limit problems using the special limits shown above right here. So if we scroll all the way up here, you recall that in the previous video, we were using these three special limits here to solve similar looking problems, all shown on this whiteboard. So in this video is going to act as part 3 in the special limit practice playlist. And if you haven't seen the previous two videos, um, shown below on the screen is a link to the worksheet we've been following. And in this video, we're going to wrap up the two remaining problems on that practice worksheet. So with that being said, let's get started. And once again, the link to the worksheet is shown below right here. And also, as usual, don't forget to like and subscribe. So let's get right into it. Okay, in terms of the remaining two problems, one of the problems we're going to solve is the limit as x approaches infinity of 1 plus 1 over 2x raised to the x. Okay, so how are we going to solve this problem? So you might recall that, this limit clearly doesn't have any sines or cosines. So we couldn't use the special limits above, right? We could not use one of these two special limits right here, right? Because the function we're trying to take the limit of doesn't have a sine or a cosine. So we can't just make a sine magically appear and hope that our problem is solved, right? So these two special limits are off the table, which means that the limit left we're going to consider is this third limit right here. The limit as x approaches infinity of the quantity 1 plus 1 over x raised to the x approaches e. And that's the limit we're going to be using to solve this problem down here. Okay, so to solve this problem down here, recall that we have this limit. We know that the limit as x approaches infinity of 1 plus 1 over x raised to the x equals e. So if you recall in the previous videos, when we were solving these special limit problems, one of the key insights was to take advantage of variable substitution. And we had to do some manipulation to the limit in order to not change the value, but to convert the limit into one where we can apply the special limit. So we're going to do that. And if you notice in this special limit, right, you have the limit as x approaches infinity of the quantity 1 plus 1 over x raised to the x approaches e. And you see that this x right here and this x right here are the same. So we have to somehow enforce that behavior in a way, right, through various manipulations in order to apply the special limit. So somehow, in this problem, we have to make a 2x appear here without changing the value. And if you recall one of the basic properties of exponents, we know that x raised to the n equals x raised to the a raised to the b, where a, b equals n, right? So this is the power of a power rule. And we want to take advantage of that property here, right? But do it in a way where we don't have to change the value. So one thing we could do is, if we have a 2x down here, right, we have to somehow make a 2x appear, right? So this limit, we have limit as x approaches infinity of 1 plus 1 over 2x raised to the 2x. But wait a second, you just changed the value of the expression, right? Introducing a 2 here isn't enough, right, in the exponent, because you've just changed the problem that you're trying to solve. So how can we introduce this 2x, right, in the exponent without changing the value? And one thing we can do is take advantage of power of a power, right? So what we can do instead is, when we have the 2x in the exponent, right, we can raise this to the 1/2 power, right? And now, if you use the power of a power property, right, you'll see that this 2x and this 1/2 will multiply, and 2x multiplied by 1/2 is x. So the exponent here stays as x. But what can we do now? we know that this limit has now become the limit of a composition of functions. Well, what's the composition? Well, the outer function is, you know, a number raised to 1/2, right? And the inner function is this 1 plus 1 over 2x quantity raised to the 2x, right? So let me make a label here, right? So this is the inner function, and this guy right here in orange is the outer function. So because we have a composition of functions, right, we can bring the limit inside, right? So we can bring this limit inside, and it'll make our problem a lot easier, right? So how are we going to do that? Well, this limit is going to be equal to the limit as x approaches infinity of 1 plus 1 over 2x raised to the 2x raised to the 1/2. And now what we can do is make our variable substitution. So if we let u equal to 2x, then when x approaches infinity, u will approach infinity. So we can rewrite this limit using that variable substitution in mind, right, as the following. Okay, so now we have the limit as u approaches infinity of 1 plus 1 over u quantity raised to the u. But what is this limit right here, right? Let me box this around. So what is this limit right here? Well, that, my friend, is e, right? Because remember the special limit right here? This form is exactly the same as this guy circled in orange, right? So this limit here is e, but then you're raising it to the 1/2, right? So the value of the limit that we were trying to solve was originally is going to be e to the 1/2. So it's the square root of e. So that's how you solve that problem. The next problem, the last and final problem we're going to solve as part of this series is this limit. The limit as x approaches infinity of 1 plus 5 over x raised to the x. All right, so this limit seems to mimic very closely to this special limit here, except in this problem, we have a 5 instead of a 1. So we can't just, nilly-willy use the special limit right now. We have to kind of convert this expression into a form that's kind of close enough to the special limit. So how are we going to do that? Well, we have to somehow make a 1 appear in the numerator and not get rid of the 5 magically, right? So what can we do? Well, we can actually bring the 5 in the denominator. And what those will give us is the limit as x approaches infinity of 1 plus 1 over x over 5 raised to the x. And now we have the similar trick here, right? We have an x in the exponent, and we have this x over 5 in the denominator. We have to somehow make an x over 5 appear in the exponent without changing the value. So we can do a similar trick using the power of a power rule. And this limit is equivalent to the limit as x approaches infinity of 1 plus 1 over x over 5 raised to x over 5 raised to the 5th, right? So now if we use power of power, this exponent is still going to be x, and the x over 5 here is going to stay as is. And now we have a composition of functions, right? Because you have this quantity raised to the 5th, and then you have the 1 plus 1 over x over 5, that whole quantity raised to the x over 5 as the inside function. So you have the inner and outer functions as discussed in the previous problem. So we can bring the limit inside. And how are we going to bring the limit inside? It's going to be as such. So this is going to be equal to the limit as x approaches infinity of 1 plus 1 over x over 5 raised to the x over 5. The whole thing is raised to the 5th. Now we can make the variable substitution, right? Because you have the x over 5 matching with this x over 5. So we can make the variable substitution, and we should be pretty much done with this problem. So let's do the variable substitution. So what are we going to notice, right? we notice that if we let u equal x over 5, so then when x approaches infinity, right, u will approach infinity. So this limit is going to be equal to the limit as u approaches infinity of 1 plus 1 over u raised to the u, all raised to the fifth. And this guy here, right, is going to become e as per our special limit. And then we're raising the e to the fifth. So the final answer for this problem is e to the fifth. And that wraps up our series on special limit problems. If you have any questions about these problems or, are confused on how I approach these, please feel free to leave comments though, and I'll try to get back to you. Thank you for watching and see you in the next video.